period. Just now we have dealt with finding the future value amount or finding the present value amount given the different interest rate, different time period, and different frequency of compounding. Okay, now what if we have the future value, we know the present value, we know the interest involved, but we want to find the time period. How long will it take, okay, for something to grow, for an investment to reach a certain amount, etc. Okay, so let's look at this. Okay, now recall that in the earlier our basic formula, okay, this is an important formula. Okay, future value is principal times 1 plus I to the power of n. Now, using algebra, some mathematics, if we rearrange this formula, okay, make this becomes the left hand side, okay, term. Okay, so 1 plus I to the power of n equals to Fv divided by P. Okay, now of course, our main concern here is to find the time period. Time period at the end is the t, our t. Okay, and we know that t contains in this n. Okay, contained in n here, right? Now, of course, this is a quadratic term. We can't solve this directly because n there it is the power term. Okay, but borrowing from, using mathematics, applying the concept of log. Don't be afraid of this log. It's our friend, right? If you log both sides, okay, so now log 1 plus I to the power of n becomes log Fv divided by P. Now, why in the world we want to use log? Okay, don't worry. The reason we log both sides is so that the n, which originally, okay, is the power terms, by applying log, n will come down. Okay, it will go down to the earth. Okay, and it is easier for us to solve if the n comes down parallel with the other terms of the equation. So by logging both terms, the equation can now be rearranged to be n times log 1 plus I equals to log Fv divided by P. And now when n is down on the earth, okay, the same level as the other terms, we can now solve for n. Okay, so now n becomes log Fv over P divided by log 1 plus I. Okay, is it difficult to find the log? It's not that difficult. Okay, when I was a high school student, yes, it was kind of difficult because we have to use the log book. Now you have your scientific calculator to do that for you, right? And by solving for n, we can finally solve for the time period t, the number of years. Okay, let's look at an example. Okay, how long will it take for $1,000 to be $1,276.28 in an account that pays 5% interest compounded annually? Now, you don't have to memorize the formula. Okay, you just have to start off with the magic formula just now, the basic formula, and you rearrange yourself. Okay, so since 1,000 is the principal, 1,276.28 now is the future value, and I equals 5%. You rearrange your formula in such a way that, start off with future value 1,276 equals to the P, present value of 1,000, times 1.05 to the power of n. Then you rearrange. Okay, so you 1,000 shift to the left hand side, 1,276.28, 1.05 to the power of n is isolated, becomes one term, right? Then you use what I have shown you earlier. Okay, log both sides. So you shift 1.05 to the power of n to the left, okay, and 1,276.28 divided by 1,000 to the right, and you put the log on both sides. Okay, and after logging them, after putting the log term, now n, okay, can come down. Okay, it becomes n times log 1.05 equals to log 1,276.28 divided by 1,000. Okay, so how do you solve this? Easy. Okay, because at the end n becomes isolated at the left hand side, and log 1,276.28 divided by log 1.05 becomes the term on the right hand side. So what you need to do is you solve this first. 1,276.28 divided by 1,000, which is 1.27628. Okay, then only you find the log. Okay, so how do you do it? Right, first you need to calculate this first. Okay, if your scientific calculator cannot solve this in one go, you can do it step by step. Okay, calculate log 1.05 first. Okay, and keep it in the memory. Then log 1.27628. Okay, you have to press log first. Then you divide with the one that you keep in the memory, log 1.05. Okay, it will give you 5.0. N equals to 5.0. Okay, notice that this is compounded annually. Okay, so your M equals to 1. Okay, so remember N is T times M. Okay, so because compounded annually, so T equals to N in this case, so it becomes 5 years. T is 5, right? So it will take you 5 years, okay, for 1,000 to become 1,276.28, okay, in an account that pays 5% interest. Okay. Okay, so far so good. All right, let's look at another example. Okay. Now, how long will it take for 1,000 to be 1,282.04 in an account that pays 5% interest, but now it is compounded quarterly? So if compounded quarterly, remember M equals 4. Okay, because of compounded quarterly. This is important. Okay, so now you can skip the long workings, right? Assuming that you have done all those workings. Okay. N becomes log 1,282.04, which is your future value, divided by 1,000, which is your present value, P, divided by log 1 plus I, okay, to the power of N, right? So in this case, okay, it becomes 0.04 to the power of 4, okay, because we are solving for N, remember? Okay, that's why we are logging them. So it becomes, N becomes 20, okay, after you do this operation, log 1.282.04 divided by log 1.01.25. Okay, remember, if you are still not comfortable using your scientific calculator, you can check the manual or check the YouTube, okay, to look at how to do this log operation. It's very simple. Okay, and in this case N becomes 20, but remember, this is not your answer yet, because N equals to T times M. Okay, so to solve for T, okay, which is a time period, number of years, okay, it is 20 divided by 4, because M is 4. So it will take 5 years, okay, for you to accumulate 1,000 to become 1,282 with an interest of 5% with quarterly compounding. Okay. Okay, let's look at another example before we go on to a new subtopic. Now, if you invest 10,000 today in an investment account that offers a rate of return of 8.5%, compounded semi-annually. So semi-annually is M equals to 2. Okay, so how long will it take for you to accumulate $20,000? Okay, applying the formula, now it should become handy to you. Okay. $20,000 is your future value, $10,000 is your present value, okay, 1 plus 0.085 is your J, okay, divide by 2, 2 is your M. So that's why I like this formula, because it doesn't matter what interest rate that is quoted, it can be as complicated as or as low as 0.000025, it doesn't matter, and it doesn't matter what frequency of compounding, okay. You can just plug in and put it in the formula for you to easily solve it. And now N becomes log of 2. Why 2? Because 20,000 divided by 10,000, And 1.0425 here is this one, 0.085 divided by 2. So your n is 16.65 in this case. And remember, finally, you have to solve for t. And since n equals to t times m, so therefore t equals to 16.65 divided by your m. Your m is 2 because semi-annual compounding. So the time period now is 8.33 years. Okay? So I hope you understand this. Okay, it is not that difficult. You just need to practice. I just give you the basic, the framework, and some examples. Okay, the rest you do it on your own with your own practice. Okay.